Okay, so Nicola, all yours.
Hi everybody, welcome to the observatory. Sorry for those of you who are elsewhere, but this introduction is really aimed at the people in the room. I'm the outreach astronomer here at the observatory, so I just wanted to welcome you all on behalf of the South African Astronomical Observatory for this special evening. And I just want to give you a quick overview of what we're going to be doing so you know what's in store. And then I'm going to hand over to Steve, because Steve's doing all the hard work. Okay? So what we're going to do, we've got an hour-long Google Hangout. We're going to be talking with experts around the world all about comet siding springs and its close encounter with Mars, which is happening at 28 minutes past 8 local time. And I did set an alarm on my phone. So if you hear ding, 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 then that's the close approach. And then once we're finished, we're going to do a little tour of our museum and our library. And then we're going to go and do some stargazing out on the lawn. And Dougie at the back there will hopefully have the McLean telescope, our old girl, working tonight as well. And for those of you who are a little bit short, don't worry, the floor moves up. Okay? So you'll be able to look up there. So that's what we've got planned for you tonight. We hope you enjoy it. And we really want this to be as interactive as possible. So please ask lots of questions. We like questions, especially those of you at the front. Okay? No such thing as a silly question. And so please enjoy it. Thank you. And thanks, Steve, for organizing this. Thank you.
Absolutely welcome. When it comes to spreading the joy of math and science, that's what we do. So to start off, we've got a bunch of very talented scientists from all over the world who are at our beck and call and at our disposal to share knowledge, because that's what we're here for. We want to know what this comet business is all about. Why is it so important? Why is it so exciting? And I'd like to get Padma to kickstart. First of all, we have this amazing comet called Siding Spring. Why are they calling it Siding Spring? What has it got to do with spring? Is it because it's happening in the southern hemisphere?
Yeah, good question, but no. Usually comets are named after the discoverers and or observatories or surveys that discover them. Comet Siding Spring was discovered in early part of 2013 by astronomer Rob McNaught in Australia at the Siding Spring Observatory. There are several telescopes on the Siding Spring Observatory area, and the one that Rob used was called the Uppsala telescope. It's a half-meter Schmidt telescope, and so that's why it is named Siding Spring. Many people actually accidentally calling it Siding Springs. It's not plural; it's a singular, Siding Spring. And since it was discovered in 2013, the official designation is C 2013 A1 because it was one of the first ones to be discovered. It's popularly known as Siding Spring.
Okay, and why is this comet such an exciting event? I mean, we've had Halley's Comet, I know that comes around every 76 years, is that correct?
Yes.
So how often does Siding Spring come out?
Well, you know, Siding Spring is very interesting for several reasons. First of all, it comes from an area of our universe called the Oort cloud, which is a far distance, it's about anywhere between 20 to 50,000 AU, 1 AU being a light year from the sun. And so it's considered to be one of those reservoirs of where comets are essentially perturbed from their orbits and kicked in towards the solar system. And so it's interesting because it's coming from an area where it's hard to predict when a comet will come in from that reservoir. And therefore, having a mission to a comet is difficult to an Oort cloud comet. Then there are also comets that have that come regularly, like you said. Halley's Comet has 76-year period. Like Enki has a 3-year period. So there are a lot of other comets that keep coming several times, and they have a certain period. So and they come from a different reservoir. So here we have a chance to be able to learn actually firsthand about a comet that has not gone through the solar system yet, and so this will be its first track through the solar system. And secondly, comets are basically remnants of our solar system formation. So by studying different comets, we start understanding how the planets, our own solar system, formed. And third, this comet is going by Mars So we are sitting on planet Earth watching a comet go by another planet. And so the early fears were that maybe the comet would impact Mars, and there are so many spacecraft around it between NASA and ESA, and now
it's me, or
and therefore the concern was that is there any risk potential for the spacecraft that are around the planet, and so. Luckily, the early studies indicated no, that it isn't. The risk isn't that high, but still there is some amount of risk that they do need to take precautions and maneuvers to put the spacecraft in safe orbits. But all of these reasons combined give us a fantastic reason to study this comet, and it's particularly in the southern hemisphere. The event occurs in the southern hemisphere for the observers to be able to watch and be able to track it. So we've been very, very fortunate that we have found a lot of amateur as well as professional astronomers in the southern hemisphere that have been observing the comet since January. And we had a hangout this morning in Australia where we saw the comet, the last view of the comet as it's approaching Mars. And it looks very interesting, and so we are hoping everything's going to work out, and we'll see a lot of interesting influence between the comet and planet tomorrow morning.
Okay, but now comets don't move very slowly. From what I can understand, comets move at something like 56 kilometers a second. So if it's moving that fast, are we looking to chase this thing and possibly even catch one? Is that even possible? Because I know that you are involved with Rosetta, and maybe you want to tell us a little bit about Rosetta and what that's all about. And is there a connection between the two?
Well, yes and no. I am also involved with the Rosetta mission in terms of coordinating observations from the amateurs around the world. Yes, and they're both comets, and so in that sense, they have that common connection. However, Rosetta's target, 67P Churyumov-Gerasimenko, or popularly known as 67P-CG, is a periodic comet. It comes around since its discovery in 1959, where Jupiter perturbed its orbit. It has become a regular visitor to the inner solar system every 6.5 years. And this is the target for ESA's European Space Agency's mission Rosetta, which was launched 10 years ago. En route to this comet, it went by Mars as well as 2 asteroids. And right now, it's in orbit around Comet 67P, with the ambitious goal of actually putting a lander, dropping a package of instruments on a lander called Philae, which is going to happen on November 12th. So all of these are unique engineering marvels and being done for the first time. And so there's a lot of excitement about that, and what it's going to do is that the suite of instruments that lands on the surface of Rosetta, of 67P, will learn how the nucleus itself is, what generates the activity that we see, and what its composition is. Most of these things are not easy to understand, because by the time ground-based observers observe a comet, there's already a coma and activity has started. So it's like a veil. You can't really see what the nucleus is like. And so here we have a spacecraft with a lander that's going to land onto the nucleus of a comet. So we're going to see it very, very close, and we're already seeing beautiful images. And then compared to that, the ground-based observers get the global environment. That is, you see the far field where you see both the nucleus as well as the tail, the dust, and any activity. And so we'd be able to compare and understand what's going on, what drives the features that we see. And so it's a very ambitious mission. It's been very successful. We wish them lots of luck, and we're looking forward to November 12th when the landing occurs. So compared to that, Siding Spring is coming in on its first path, and even if it comes back the next time, it'll be thousands of years that we may not be here, but or it may not come back. So it comes from a different part of the comet reservoirs. Also, it's going to be a once-in-a-lifetime chance for many of us to actually see its swing by Mars. It's not. And it's going to be the closest. The passage is going to be the closest of comets to any planet It's going to be, given the distance between Earth and the Moon, this is about 1/3 the distance of that. So it's a very close passage, flyby of Mars. So comets in general tend to basically come from similar areas as far as formation, as well as their orbits and stuff like that are concerned, in the sense that, yes, they're visitors through the solar system. Their activity is what we monitor, yet what they consist of and what drives that activity is very different. So each comet is pretty unique by itself.
Okay, now we've also had a couple of emailed questions, and we have a student in India, Jalva Hussain from India, and he wanted to know, will the comet have any effects on our satellites or anything in space? And from what I can gather, and maybe even Jim from NASA. Hi, Jim. How are you? I'm hoping that maybe Jim also from NASA could shed some light on some of the evasive moves that NASA is making, because they are a little bit worried about potential damage to their equipment.
Well, you want me to talk now, or you want me to talk later?
Well, let Padma answer the first bit about, obviously, will it have any effects, and then maybe, Jim, you can mention about, what NASA's plans are.
Okay, all right. Well, there are, currently, including NASA, ESA, and India's space agency, ISRO, there are 5 orbiters around Mars right now. And so the big concern is the dust that is coming towards them from the comet, even though it's old dust generated about a year ago, and is that going to have any damage and potential for damage? So from the modeling that's been done, the dust is moving slow enough that the impact isn't very high. However, to be on the safe side, any dust particle can always damage anything in space because of the relative velocity between the two objects. However, from what I understand, the risk mitigation models indicated that it's going to happen. Even if it happens, it's going to be a few %. But to be on the safe side, I think ESA as well as NASA assets, the orbiters, have been maneuvered into such a way so that they're actually behind of Mars, so that the comet, as it passes by, it'll be on the day side of Mars, and the other orbiters are going to be on the close to the night side, I believe. I'm maybe off on that. India's mission, MOM, their spacecraft is in an elliptical orbit, so they're pretty far off. They'll be able to probably take observations of the different payload, different instruments on their payload, but it's far enough that I don't think they're having any risk mitigation plans in place. They're just in a very long elliptical orbit. But I think probably Jim may be able to shed a lot more light on that question.
Actually, I think, Padma, you hit it exactly on the head. And hit the nail on the head. You said exactly what I would have said. I would suggest, though, that as the comet flies by and envelops Mars in its tail, it's going to provide us with an unprecedented opportunity to make measurements of the debris and its interaction with the Martian atmosphere. And I might actually ask Henry if he knows anything about that. I'm not fully versed, but I know that MAVEN's got a lot of particle instruments on board, and there are imagers on other satellites that might be able to take some pictures of the resulting impacts on the upper atmosphere of Mars.
Henry, do you have anything to add to that?
What I'm doing is ground-based observations from the Earth. So, Padma probably knows the most about the spacecraft observations.
Yeah.
Well, Steve, if you don't mind, I sent you some images. If
you did, I can load them up. You tell me which ones.
Okay, there's one. Could you pull up the one called NASA Assets? I've basically borrowed from a lot of the NASA visuals that I've been seeing over the last few weeks, and I think this might help. This was shown in one of our press conferences recently.
Okay, what I'm going to do is I'm just going to expand it a little bit, and then I'm going to share the image so that everyone can see it as well. Let's go to the Google Hangout and share screen, and let's see if technology is on our side tonight. So far, so good.
Good. Okay. This is one of the most popular visuals I believe I have seen on the internet. This was shown at a press conference by Jim Green, the director of the Planetary Science Division Directorate at NASA headquarters. Now, these are all the different assets in terms of NASA assets in terms of missions. You can see there's the Mars Odyssey, MAVEN, ESA's Mars Express, and the 2 rovers on the surface of Mars, Opportunity and Curiosity. Also, the ground-based telescopes, IRTF, NASA's Infrared Telescope Facility in Hawaii, a balloon experiment that was recently performed, BOPS. So these are all the various assets that are observing Mars and the comet from Mars location. And if you could go to the next visual, this will give you a kind of an idea how many observations are being planned by this entire fleet. It's called NASA Comets Observation. If you look at that visual.
The computer will behave itself. Did it switch to the next picture?
Yes, it did. Perfect. So if you look at this one, this tells you the planned science observations by the different instruments on the different spacecraft. And so, and if you go to the website for Mars.sighting JPL's website, you will see that there's a very long graphic that shows you exactly when each measurement is going to occur. So I didn't put that in here, but people are welcome to go to the website and basically see each of these observations, science observations, when it's going to be done. And so it's a marvelous program whereby on short notice these spacecraft as well as the rovers are not meant to be looking up at the sky but looking at Mars and its atmosphere, and they've all been engineered just enough to be able to actually do a lot of science on the comet. And like Jim mentioned, as the tail and the coma of the comet goes by Mars, one can actually do a lot of in situ measurements and also get maybe a very close look at the nucleus, which we have not been able to see. And so it would be interesting to know if it's one piece, several pieces, what's in there. And so these are all the observations that taken together will give us a whole picture, and then these will be complemented by ground-based, like what Henry and I are doing, and also the amateurs are doing. And so, this is unique science. As Kelly Fast, a project scientist from MAVEN, said, we can't always go to the Oort cloud comets, but here is a comet that is coming to us, and now it's a perfect chance to be able to measure all these different aspects of the comet.
I mean, from what I can gather, the remnants of this comet are something like 4.5 billion years old, and it's a very rare opportunity to actually analyze things that old. Is that correct?
Yes, you don't. Most of the time, we only do ground-based observations because by the time we recognize that there's a comet coming in from the Oort cloud, we don't have enough time to make these kind of measurements, and they don't always go by planets, especially planets where we have so many assets. So we are very fortunate, and this rare occurrences are happening when we have the technology, a lot of spacecraft, and we had ample time to coordinate on the ground between different telescopes, communities, robotic networks of telescopes, amateurs, and so everybody is engaged in studying this comet, and that is, and I think this is you can consider something like a cousin to ISON, which also came from the Oort last year, if you recall, and it was interesting because it went by it was scheduled to go by 4 of the inner planets, right, all 4 inner planets, but it disintegrated on its perihelion day, and so we got some wonderful data which is still being analyzed, but this is what is interesting. We don't know why these things happen and the processes that govern them, and so here is a very complete set of observations that we couldn't have designed had we even thought about it. So to have this comet come to us at a time when when all these assets are there, the technology is there, and we have also the entire world wherever they can observe are observing. This is fantastic, and so I'm hoping that it will keep us busy studying, analyzing this data for years to come.
Okay. Well, we're very fortunate because we've got 2 people who are out in Sutherland which is quite a remote area in South Africa, a great place to observe the stars and all the excitement that's going up there. I'd like to start with Dave, because I know that Dave's busy doing some observations. What time is the actual pass supposed to happen? Approximately now? In 4 minutes' time, we're supposed to have the moment when the comet actually passes Mars, and if you blink, you might miss it, because I noticed that Dave is busy working with very fine detail on the computer screen, and it's basically a dot moving around. And I was saying to him that it's almost esoteric. Unless you know what you're looking for, it's just a dot moving around the screen. It could be a chocho climbing all over the screen, like a little gnat, whatever. Dave, are you able to give us a quick view of the big telescope that you're using to check out the actual passing?
Well, I'm not actually observing it. I took some pictures the other day which Nicola has.
Yes, I have that, and I'll put it on for them.
I can show you the telescope here, which is a very small telescope by modern standards, of course. You want me to do that now?
If you can just take us on a little tour, yes.
Yep. Okay. Well, I normally work in this little room, which is just off the main dome, and I'll just walk you over here. I don't know if you can see. These are just the displays from the computers that run the telescope and run the instrument, and then
virtual outing.
There's the telescope. Of course, you can't see it terribly well because you can't get far enough away.
How do we know that's not a transformer?
That's the main barrel of the telescope, and then at the bottom end there you can see the instrument. Can you get that?
Yep, we can.
That's not the instrument, that's CUNY.
And that you mentioned was the very high-powered CCD, the sensor.
That's right. It's actually, again, it's quite a small CCD, but astronomical CCDs. It's inside this box here. Astronomical CCDs are selected to be of very good quality, so it makes them very expensive. But in principle, they're no different from the CCD that you would get in a digital. This instrument here was used to take the pictures that I sent the other day. Oh, sorry, that was just the dome moving because the dome was on all.
We thought something had just happened. The comet went past Mars.
I do creep quite a lot, but that wasn't me. That was the dome. So that's the bottom end of the telescope you can see, and if I move back a bit, you'll see a bit more of the. You see now I'm almost at the wall there, so you can't get very far away. But that's
so it's
the dome.
The big beast.
Well, the mirror at the bottom, which is the kind of yellow circular. You see the yellow circular bit there. That's the mirror that contains the mirror. That's 1 meter across. So it's 1 meter worth of glass. It's several, I would imagine about 15 or so centimeters thick, and it's aluminized on the front surface, so it reflects light back up to a mirror at the top end, which then reflects mirror back down through a hole in the primary mirror with a detector. And by modern standards, this is a small telescope. I mean, the biggest telescopes in the world are about 10 meters. The mirrors on those would hardly fit into this room. They would be of the same sort of size, probably a bit bigger than this whole dome. What is the largest
telescope in Sutherland?
The SALT, which is, it's actually a bit different from this in that it doesn't move about the sky as this one does. I can point this all over the sky. SALT remains at a fixed altitude, and the mirrors are about 11 meters across, which, as I say, is probably bigger than this whole room here. If you look at the size of that floor, they're bigger than that, but they're segmented mirrors. It's made up of about, I think, 91 separate segments. and that is about 11 meters across, as I say, but the way it works, you don't use the whole of those mirrors all of the time. So effectively, it's about 10 meters across, and that's about as big as there are any telescopes in the world. Salt was copied from a design at McDonald Observatory in Texas, and there are other single telescopes which work pretty much like this one. They can point all over the sky, which are about 10 meters, 8 to 10 meters across. They're extraordinarily expensive to build by astronomical funding standards, but glass that amount of reflecting.
Mm-hmm. And can you see footprints on the moon with a telescope
with a small
like this?
telescope. No, like this. Because one of the limiting factors is that we have an atmosphere above us. We have about 100 kilometers, sorry, or so of atmosphere above us, and it's got clouds in it. So it spoils what you can see, and that of course is why space telescopes are so important, because you don't have that atmosphere to look through. But no, you couldn't. If this telescope, sorry, go ahead.
Sure.
Okay, is that fine?
You're breaking up a little bit.
No, it's just age. I
thought maybe we'd hear another funny noise and the computer would go flying or something.
Well, as long as it's not me breaking up. If it's just a signal breaking up, that's fine.
All right. We just want to quickly switch over. We've got Mokinia. You are sitting in Sutherland too, and you are a UCT student studying astronomy. Why should we study astronomy? What's the big deal? Why are you studying it?
Hi, Steve. I'm studying astronomy just because of the passion, I guess. I've always been interested in the universe and how the universe works and stars, and I figured, why not? I can't exactly see myself doing anything else, so yeah, here I am observing in Sutherland.
What did you study to get there?
So for my undergrad, I studied physics and applied maths at Wits University, and then my postgrad, I came to UCT, and I did the NASP program. That's the National Astrophysics and Space Science Program. And I did that for my honors as well as my master's. And right now I'm doing my PhD at UCT, at the University of Cape Town, as well as at the South African Astronomical Observatory.
Now you see, this is what pleases me, to see not only young South Africans that are talented with maths and science, and of course you're a big fan of maths, is that true?
Yes, definitely.
Okay, but more importantly, we have young black women, role models, who are taking it to the next level and showing people that it can be done. And that's critical. If you want to get people involved in the maths and the sciences, you need role models, and of course Mokinia is definitely one of those outstanding role models that excite me to no end. So now, what are you actually doing at the moment in Sutherland?
So at the moment, I'm observing something called cataclysmic variables, or otherwise known as CVs, and they are mass transferring binary systems consisting of a low mass main sequence star like our sun, as well as a white dwarf star, which is towards the end of its life cycle. And I'm just observing them. They transfer mass. The mass is transferred from the main sequence star to the white dwarf, and they undergo outbursts quite regularly called dwarf novae outbursts. And yeah, these are very interesting objects. They have accretion disks surrounding them, so we're very interested in the accretion that goes on with these objects. And some of them are very specialized. They have highly magnetic systems, which has a completely different accretion system. And yeah.
Wow. So for those who didn't understand a word that Mokina just said, she said she spends a lot of time looking at computer screens and things that move up and down on the computer screens, and some of it is related to space as well. Did I get was I close? Something like that.
Spot on.
But of course, we're not only blessed to have Mokina and Dave, we also have Clyde. Clyde, you are a bit of a fundi when it comes to dust. Can you tell us a little bit more about dust on Mars and why you mentioned something earlier to me today about a dust storm, and is that anything to do with the one that happened in Gauteng recently?
Hi, Steve. Hi, everyone. Hi, Padma.
Oh, hi, Clyde.
Steve, it's connection there?
Yeah, we got you. We got you.
Yes, I've had a fairly long, lifelong interest in astronomy, but earlier this year I managed to upgrade my observatory, and as it happened, that coincided pretty much with Mars's closest approach to Earth recently. And I actually got fairly involved in taking images of Mars, and have been taking images as often as possible, almost every night over the last 4 or 5 months. But during that period, I was able to catch a couple of dust storms, which particularly about the period of July. That was the southern winter on Mars, and it's quite unusual to get significant dust storms then. So it caused a little bit of a stir, if I can use the pun there. But subsequent to that, I've picked up a couple more dust storms. There's actually one which is currently taking place at the moment. And I was managing to catch another image this evening. I've been following that one quite closely.
What's the big deal about a dust storm?
I think it's, yeah, look, my interest is probably more from the fact that I've got a passion for learning. I've had a lifelong interest in astronomy and the universe, and to be able to see what is going on another planet virtually in real time, to me is fascinating. But I am obviously circulating these images around the world, virtually on a nightly basis, and certainly the specialists who are picking up on the images, making comments, and to have that interaction to me is something very, very special. I think even for people at NASA who pick up on the images, I think they're obviously watching carefully in terms of the impact on the orbiters, on the rovers, and yeah, it's for me it's more from a fascination perspective, looking at another planet and being able to watch it in real time.
Wow. And maybe Padma, maybe you can help us. I mean, obviously Clyde is sending these pictures of dust storms to you. What is the use for you?
Well, you know, this event, comet sighting spring going past Mars, is really two campaigns in one for us. One is to study the comet, but also we've been observing Mars for quite a while, and Mars has seasons like Earth, so seasons have been changing. Like Clyde said, when he started observing, it was closest to Earth. That was back in April, I would imagine, April-June period. But every few months, Mars undergoes different seasons. So right now, we are in the northern fall part of it, which is the dust storm season. When the dust storms that occur on the planet, they basically obscure the atmosphere, so your opacity changes, and so that could affect, one, what you see of the comet, and two, if there is a cometary dust and there's interactions, so some of these things, these influences will probably be known later. And also it's good to know this, the system, the atmospheric system of Mars as we are watching the comet, to characterize the planet itself. In fact, I think I have a visual of Clyde's recent image he sent us. If you could bring that up, maybe Clyde can tell us what he's seeing. But
okay. Which image you're looking for?
It's called Clyde_Mars. And
Clyde,
so
side_Mars. Let's see if we can find it. Under Clyde.
Right.
Let's see. Just waiting for this thing to work. Here we go. This one. No. Is this it?
It says Clyde_Mars _18.
Yeah, I think we got it. We got it. Okay, I'm going to share it now with the screen.
Okay.
Let's go with share screen, and I believe that's the one. Okay. Yeah.
Okay. Well, you know, given that there are so many spacecraft around Mars monitoring the weather there, so to speak, the climate and the weather, and ground-based astronomer to be able to look and see in a 6 arc-second disk that we see right now, to be able to identify dust storms is something interesting and unique. And so as the dust storm started, Clyde, I think on, was it October 5th, one of your first images that I saw actually had a dust storm. And these storms essentially start at the northern latitudes and they cross the equator, so they're called cross-equatorial storms. And Mars has a season for these storms, and sometimes you get the huge global storms, and sometimes you get regional storms. So these look more like the regional storms, but it's interesting to know that as soon as we enter the dust season, the event is happening around that time, and these images, I believe, are from last night, and I think your RGB as well as the R image, I believe, show the dust area much better than the rest of them I applied. Would you mind describing your slide for us, please?
Yes. If you look at the image on the left, you've got the RGB image, which is a combined image of the red, the green, and the blue channels. So when we image, we actually take through different filters. Now, there's a reason to do that. Number one, I won't go into too much detail, but by using a mono camera with filters, you're able to get or to utilize the efficiency of the camera a lot better than using a color camera. And what we do is typically I will image for a period of about 120 seconds through each filter, and during that time period you're capturing an AVI, a video film, typically between 20 and 50 frames a second. And then there's some very nice software that we can use to process the image, to certainly make it clearer. Now, as I mentioned, you've got the RGB on the left, and then you've got the 4 filtered images on the right-hand side. You can see that the blue image is not a very good image. Typically, what that does is it picks up the vapor clouds on Mars. So typically, for example, the water vapor clouds. And you can see down at the bottom and at the top, in the polar regions, there's maybe a little bit of cloud there. Also in the infrared, the IR742, it's taken an infrared which often gives quite a little bit of detail. But if you look at the red image, you've got a dark area in the center of the planet, which is called Syrtis Major, a very well-known feature. But just to the left of that, you can see a fairly bright area, which is typically what you would expect to see in a dust storm. It would show fairly strongly in the red channel, and to a lesser extent in the green channel. And you can still see a little bit in the green channel of the storm. But again, in the RGB, you can see it's standing out fairly brightly. Steve, I don't know. I've actually processed my red image for this evening. I don't know whether we want to try and have a quick look at that. There's actually a couple of changes. Typically, the storm is what happens is that on last night it was fairly concentrated, and what it does is over a few nights it tends to expand and dissipate. That's certainly the experience that I've had with the 3 dust storms that I've managed to capture. But if you look at the red image, just to the upper right of the Syrtis Major region, I also picked up quite a change this evening. So it appears that there may be some dust activity up towards the top there above Syrtis Major as well. So, as I say, there's these to me, this is all part of the excitement of seeing another planet in real time, the changes that are taking place on a day-to-day basis, and certainly it brings a little bit of excitement.
I'm sure. Now, Jim, you wanted to say something about the surface weather? Just one little comment you wanted to make? Let me just unmute you. I think I muted you for a second.
Yeah,
okay.
Actually, I hate to admit it, but Steve, I've never actually used a Google Hangout before, and so I had to have my son show me how to log in. So when I turn my camera off, you see his icon and not mine.
That's okay.
Anyway.
If we're in anime, we're okay with that.
I have to admit I have no idea what that graphic is from. Anyway, when I was helping with Jim Green to run the planetary science division at NASA, this was before we landed Curiosity on the surface, Spirit and Opportunity would routinely see the solar array power go down as they traversed the Martian landscape, and that was because they would kick up dust and then it would be attracted to the solar rays. And we would often wait for dust storm season, especially for things called dust devils, to come around and blow the dust off the solar rays, because then we would get just a little bit more power output. Solar rays only, when they're brand new, only put out about 140 watts or so. And so you can imagine putting a thin coat of dust over them would reduce the efficiency, and therefore the power output would go down, and that would mean it would either get colder at night or there were certain instruments that we couldn't operate. So we would routinely wait for the dust to be blown off by the surface turbulence. So watching all of this stuff is very important to begin to understand the weather patterns on Mars. Curiosity is a little different. Curiosity has a radioisotope power system, which is nuclear driven, so it doesn't actually, it's not as severely impacted by dust collection, although it does have thermal radiators that also need to see space. So.
All right. We've got Alan, who's doing out. He pops in every now and again because, let me just, okay, I've muted him. Alan, are you able to hear us?
I can hear you, yes.
Okay, great. So now Alan is standing outside with his telescope. It's completely dark, is that correct?
Yeah, well, it's not entirely dark. There's some dim lights from Joburg about 20 k's away, but definitely dark enough that you won't see me if I turn my camera on.
Okay, can you tell us what are you doing at the moment?
Yeah, at the moment I've got the telescope set up. I've got my camera attached. It's pointed at Mars directly, and I've got it capturing a sequence of images, all quite long exposures. And one of them I thought I could make out the comets directly, and I've shared that online. But the plan is to then take those images, there's about 70 or so, and digitally combine them to bring out the details and just reveal, and hopefully I'll be able to see something.
Now, you are an astrophotographer, is that correct? No, we've lost him. Okay, so he's on his cell phone and it's in and out. Before he comes back, Henry, I don't want to let you sit there and think that we're not going to be chatting to you. So let me put his on unmute. Are you want to unmute your mic?
Okay,
there we go.
Here I am.
Henry, tell us a little bit about what you do. And I mean, I know that when we were at the National Sci-Fest, and we will obviously chat to Anya as well, because she's sitting there, being very, very quiet, which is very unusual for Anya. We know that you made little mini comets at the Sci-Fest, and we would love to hear a little bit more about what you're actually doing at the moment. And I mean, obviously you don't sound South African, so what are you doing in South Africa?
Well, so what I'm in Pretoria right now. I'm from the States, but I've been living in South Africa for the last couple of years. And one of the things I've been doing is observing comets. So I actually have a couple of observations running on a network of telescopes, which is called the Las Cumbres network. And it's a network of global telescopes. I think there's about 15 telescopes, which are essentially scattered around the globe. And the situation is there is, right now from South Africa you can see the comet, because you can see the Mars and the comet because they're up in the sky. But they're going to set in another hour or so. And but what if you want to watch something which after it sets? What you can do is you can hop over to Chile or Australia or something like that, and watch it from there. Because just like the sun, when the comet sets from one place on the Earth, it's rising in another place. And so this network of telescopes is set up so you can actually monitor the same object, up to 24/7, depending on kind of where it is in the sky. With this comet, we can't quite watch it 24 hours a day, but we can watch it maybe 6 hours a day or so, because there's telescopes in Chile and in Australia and in South Africa. And so I have some observations where we're not trying to do observations, we're not focusing on right now, the close event of close approach. But what we're doing is about 3 weeks of observations to put the changes in the comet in context, and see how it's getting slowly brighter and slowly darker, and see how it's rotating and that kind of thing over sort of throughout the whole month. And so observations are running right now from Sutherland, I hope.
Wow. And what got you into astronomy?
Oh man, I was done with my BSc in the States, and I didn't really know what to do. And astronomy seemed really fun, and I applied to postgraduate programs, and I got rejected by all the physics programs, and I ended up in astronomy, and I loved it. And so what I mostly study is the solar system. I think the solar system is great because it's really close. I mean, it's very, very different to study things inside our solar system than stars and galaxies, because no matter what you do, you can never go and touch a star or a galaxy. They're to me a little less tangible, versus these comets. I mean, these pictures from Comet CG, where you're seeing boulders, you're seeing rocks. You can land on it. You can pick up a rock. You can stick you can taste it. You can really get right up to that comet or planet or land on it. And so it's the sorts of physics which is very directly relatable to the sorts of physics that we observe on Earth every day. And that's what I really like about doing the solar system studies.
Sure. Okay, so now apart from Henry, who's obviously a big fan of the solar system, and all the others that we've had join us, I know Alan is busy taking photographs and stuff. Alan, if you can hear us, I was going to ask you one quick question. How does one get a great photograph of the Milky Way? Because a normal SLR, when you're pointing and holding it in your hands, it just comes out as a big blur. What's the secret?
Well, the problem there is that the Earth is turning, and over a long period, those stars move in the same way that the sun moves across the sky. So you need something to put your camera on that will move it exactly to counteract the motion of the Earth. I think the classic way is to buy an equatorial mount, which is normally used for a telescope, but you can make one yourself. They call it a barn door mount. It's a simple hinged piece of wood. You need to be a bit clever with the gearing to make the thing move correctly, but they are quite simple. It can be done at home. Was it Scopex, the Telescope Expo a few weeks back. There were quite a few good examples there. So yeah, it's just about controlling the movement of the camera to exactly counteract the movement of the Earth.
And can you take it with a cell phone? I mean, is a cell phone good enough to take photographs?
Wow, I've never seen anyone try. I wouldn't think so. I think a compact camera, those little point and click ones that you buy. Oh, I'm sorry, the dogs are going crazy in the background. I don't know if you can hear them.
That's all right. We love the ambience. It's fantastic. Meet you outside.
Yeah, the neighbors just come home and the dogs are going crazy. Yeah, I wouldn't think a cell phone camera could do it because the lens is simply tiny in those things, and they don't collect much light. But I suppose it's possible if you could put an app on your phone that'll let you take a very long exposure.
And when you next come down to Cape Town, maybe we can talk about getting some camera enthusiasts together to do a bit of a workshop on astrophotography.
Oh, I'd love to do that. Yes. Yeah.
Okay, you all heard that. You have witnesses. Thank you, and people on the internet, you heard that too. Quickly, I sort of ask Anya a question. Now, Anya is the director of the National Science Festival, so I'm very pleased that she's joined us as well. How important is it to promote maths and science to as many people as possible? What's the big deal?
Well, Steve, I think as you've heard tonight, it's pretty damn near impossible to do astronomy without maths and science. But maths and science just teach us so many other skills that we need to really just get through life. How to reason, how to deduct things, how to think logically. And we use it in all aspects of our lives. We have this conversation all the time about how important science is to art and how important art is to science. So really, these are the building blocks of reasoning and of logic and of life as we know it, really.
And in terms of SciFest, do you have a big excitement towards the space sciences, or is it mainly just engineering and mechanics and mathematics?
No, space science is just so sexy. It's even in South Africa, we just have such an imagination for space science, even though we don't have, massive space agencies yet, let me add. We've just actually completed a week-long outreach here in the Eastern Cape, specifically looking at space sciences. It's part of an extension of celebrating World Space Week. And, we specifically looked this week at, of course, the encounter, building satellite models. And I think really space just, it's just something that gets the imagination going. So it really is, it's a very big focus for us. And we use space sciences a lot, to really get people to be interested in maths and to be interested in science. We even, sort of go a roundabout way to get them interested in the life sciences. It really is, it's a fantastic tool, fantastic subject to use to get people interested in maths and science.
When is the next National Science Festival, and how do we get people to come?
The next festival runs from 18 to 24 March next year. It's always the best time in Grahamstown. And really, the participation forms are online, registration forms are online as well. But if you're interested, to find out, more about participating in SciFest, just drop me an email. It's very easy. I'll pop it on the group chat. It's .org. Let you know about the theme. The theme for next year is, of course, Science Alight, which celebrates the UN International Year of Light. So more than enough scope for astronomy and space sciences at the festival.
Now, without giving away too many secrets, I'm just going to put it out there, and maybe Jim is listening. Are we going to get any spacey type special things happening next year?
No pressure, Jim.
Way to put me on the spot, Steve.
No. I mean this is just between us and the rest of the world that are listening.
Us and the world, right? Yeah. I think it's likely that some very interesting things will happen around SciFest next year. Right. And what that's going to be is really going to be hard to say at the moment. But if I were living in South Africa, I would want to mark the dates and plan to be there.
Watch the space, Steve.
Watch that space.
No pun intended.
All right, and then of course, I just want to mute because I think some of them are listening to the YouTube link as well. Padma, we're going to end off with you because, of course, we've got a bunch of people over here, and I'm just going to turn around so everyone in the audience can be seen as well. Can you all see the audience? We're going to turn the lights on.
Yes.
Does anyone have any questions for Padma or any of the panel? Yeah, we have a question. Fire away. Did you hear that?
No, I'm sorry, I couldn't make it out.
The Mars rover, for example, are going to be taking visuals of the passing. Will they be taking visuals with their cameras?
You know, I'm not completely sure, but I think yes. If you look at that visual I had about which Mars assets were going to be taking observations, I think the problem with the rovers is that it's the comet as it flies over is available at twilight, and so I think they are going to be trying to be looking at the comet, and if possible, around that time they will be trying to take some pictures. But in fact, it's happening today. A lot of the Mars assets have been taking images and data for the last couple of days, as well as they'll be doing. There are lots and lots of different observatories as well as experiments going on in terms of taking the data. Hopefully, in the next few days, we'll find out what kind of images and information that the spacecraft as well as the rovers have taken.
Okay. Any other questions? How close is this comet? I mean, could this comet have hit Earth?
No. I didn't do all the calculations, but no.
Could a comet hit Earth? In general, could a comet hit Earth?
Yes. You know, in general, yes, it could. But I think the probability of that happening is a lot smaller than asteroids that you can't really see, and so they're much darker, and therefore it's harder to spot them, and that's why I think there's the Near Earth Asteroid Program and other agencies do similar programs to try to track asteroids around the Earth to hopefully keep us safe. But you know, 20 years ago, though, Comet Shoemaker-Levy 9 basically split into many fragments, and all those fragments eventually started over a matter of a week. And in fact, Jupiter acts like a vacuum cleaner, so that these kind of impacts from objects like that can be essentially absorbed by Jupiter, and it protects us in a way by shielding us. And so that's why the probability is pretty low for Earth to be hit by a comet. But you know, things do happen. But right now, I don't think so.
So you're not particularly worried at all?
Well, no. I think you put on a great show, and we know where it is.
You're not worried. We're not worried. The question on this side over there. Can we just turn around?
But Steve, if it's possible, may I share a couple of visuals? A couple of them
While
are.
you're sharing the visuals, one or two people wonder, what is the comet made out of? Just while you're sharing the visuals.
Okay. While the comet, well, you know, originally Fred Whipple's model was it was a dirty snowball that is mostly ice and with contaminants. But the picture seems to be changing a little bit. You know, looking at that nucleus of 67P, the target for Rosetta, as well as other new comets that have had flybys, like Halley by Giotto and recently Comet Hartley. This tend to be very, very dark. And so is it an ice with contaminants, or is it something darker with ices embedded in it? And so those are the things that we are starting to question and understand. And so these kind of observations and these missions are very, very crucial to that. So it has water. It can have water ice, different types of ices, volatiles, hydrocarbons, and dust, especially dust. And so it's a mix of a lot of things. But in what fraction and how that process is processed is what we don't know yet, and that's what we're trying to learn. And so one of the visuals I'd like to show, there's several I want to show on different topics, but basically in question to the impacts of planets, if I could have the one that says, where is it? Not the star chart. Can you look up, yes, the DLL2.gif. If you could open that, it basically shows a comet.
This one.
Yes.
Let's have a look. This is the one.
Okay.
I'll share it with you now.
Okay, because I had a visual of SL9 and its fragments before it hit Jupiter. And
is that it?
Yes, well, this one, okay, that's fine. This is actually Jupiter, but this is now being seen by Galileo spacecraft, which was in orbit at that time when SL9 came. And so this is looking at fragment W. There were about 21 fragments, and they're named by the letters of the alphabet. So W is one of the latter ones and a smaller fragment. But this is Galileo looking back at Jupiter and essentially seeing the fragment coming up from the south and impacting in the atmosphere. But what I wanted to show really was essentially this is what Jupiter does. This happened in 1994, and 15 years later, we have what's called the bird strike. Anthony Wesley, a very prominent planetary imager from Australia, saw a mark on the planet and then informed the professional community because he couldn't identify it as a shadow of a satellite. And it turns out it was the comet that hit Jupiter, and again we were able to rally the ground-based as well as all the orbiting telescopes to look at this strike. And if you could bring up the visual that says Bird Strike 2009, it'll give you an idea of what the mark looks like on Jupiter that we were able to observe with HST as well.
Strike 2009.
It's called Bird Dash Strike, yes.
Okay, is that the one?
Yes, I don't see it on my screen yet. I don't see it on my screen yet. Okay.
Not showing it?
Nope.
No, it's fine. I'm going to share it now. 1 second.
Okay.
And let's go to this one here.
Okay, this is the one. So this strike took place almost to the date, 15 years after SL9 did, and so this was you can see the dark spot, and that's what Anthony Wesley informed. And this is the advantage of the amateur astronomers, that they observe nightly on objects that are fancy them, and when they see something different out of the ordinary, they immediately contact the professional community. And so this is basically taken with the wide field camera on Hubble. And so you can see this spot lasted for quite a while, and it evolved differently, and then other telescopes were able to observe it too. And so, yes, impacts can happen on planets, but I think Jupiter's position and its size, its gravity, all that only helps in protecting the inner planets to some degree. So it's not to be taken lightly when I say that there isn't a good probability, but you shouldn't be scared about it either. There are a lot of other calamities that can occur. But the other one, I do want to show our observers around the world. Like Henry mentioned, you can't follow this unless you have either a fast enough plane that goes around the world, or many telescopes all around the world, or even a network of many amateurs with their own telescopes around the world. So if you could show our observers map, it'll show, it's called PACA Observers Map. That will show really where we have people, and this event is happening in the southern hemisphere, and so people in the northern hemisphere, even though they can't observe it, they are observing through robotic networks, that is, like Henry mentioned, networks that have telescopes distributed around the world, so they can access them remotely. And we had a very interesting session this morning where we actually took images. And so here's a map. Henry mentioned a network of telescopes on one network, the Las Cumbres, and here we have lots of individuals as well as telescopic networks around the world that are participating in this campaign for us. And so right now we are focusing on observers in South America, Africa, well, there are two to three pink dots there, and Australia. And so we just did a morning, we did an observing run in Australia this morning. Right now we are here in South Africa for the event. And there's a telescopic network called stu.com that's having its own show from Chile as well, because they've been observing from there. And so, and I've just recently seen an image from 42 degrees north from Gianluca Massi from the virtual telescope. So it's amazing. It's a challenging observation, but it's surprising how many people are getting involved. And so this is the advantage and the power of the amateur community. That is it's a synergy working with the professional. And so it helps us to be able to partner with them, and whenever they see something, they can immediately contact us, and interesting science comes about. We learn more about our solar system through these interactions. And I would like to leave to show two more, if I may. If people have questions, they can ask, but I would like to show two visuals. One is the movement of the comet as well as Mars over the last few days that was put together by several amateurs in our group, as well as taken images from today, which is, it's called, okay, where did it go? I'm sorry, it disappeared for a minute. If you could look at the one that says Andreas Composite, that's one of our members who's a graphics designer, basically put together several images and shows this event happening. So if you could bring that one up, Steve, I think it'll put this event in perspective for lots of people. It's called, okay, do you have that?
Okay.
Okay. All right. It's not looking as nice on this because this is done hurriedly, and we kind of put together different images. What you're seeing is Mars going from the south, bottom of your picture to the middle, where the image up there is bright because today this was taken this morning, and it's really bright. It's dominating the comet, which is very faint compared to the planet. And from the top going down, you see the comet position at different locations, and this is the same scale on every night. And so this is where we are. This is in Australia this morning, and so we're hoping that over the next few days the comet is going to go by the planet, and then we can see them separate and see if any changes have occurred in terms of dust or any other things that could possibly happen. So this is one of the visuals, and so we're trying to add data to that with Alan, Koss, and Clyde here. But also the other last visual I would like to leave you with is the contribution that we, during SL9, that was made by the South African telescope. I believe it's called SAAO. If you can pull up the visual that says q-saao.gif, it's basically following fragment Q from SL9 impact, and it shows the kind of observations that can be taken, and that should, it makes the assets in South Africa very, very valuable for campaigns like this. And so here is basically what you're seeing is Jupiter, and you're seeing that, oh, I'm sorry, I think I lost my visual here. You're seeing Jupiter, and you're seeing a lot of bright spots, but the one that on the leftmost is the new impact Q, and the other bright spots are impacts from the previous fragments. But this is from the South African Astronomical Observatory, and I think it's a fantastic testament to what kind of science can be done from South Africa. And I think this is something that you should pursue.
Well, thank you so much. What I would like to say is I'm going to turn the lights on to the audience again. There we go. Some eye candy. Otherwise, you have to look at me, and you're observing enough planets enough. What I do want to say is that citizen science is an incredible opportunity for everyday people to get involved with scientists around the world. The fact that we can now connect all these scientists together in one Google Hangout, and it all happens here in Cape Town. The fact that we are utilizing our top scientists around South Africa, and they are contributing, and NASA and other reputable agencies are using their content. These are amateur astronomers who are sharing their content, and it's being used by agencies like NASA. I think it's a wonderful thing that everyday people can get involved in the science. And tonight, we're going to show you how to put that in action. We're going to get that spark going. We're going to do a little bit of observing outside. And are we going to be able to check out Saturn? Mars and maybe Saturn? 2? Is it too low? Okay, well, we're gonna observe a few things, and hopefully that'll kickstart your excitement with regards to astronomy, and we'll see a few more of you at Sutherland, and in a few years' time, when another comet is flying past, we'll hopefully have some of you patching in on Google Hangout, possibly even flying a craft that will land on the comet to extract some of the particles and bring them back to Earth as well. So I would just like to say thank you very much to our panel of speakers. We have, at the moment, we still have Padma from NASA. We have Jim Adams from NASA. We have Anya, who just reminded me from the 18th to 24th of March is SciFest. So if you'd like to make sure that your school's got an outing there, it really is a fantastic week of amazing science, engineering, maths, everything goes on, especially space. And as you heard from Jim, you can't say what, but it'll definitely be worth going to SciFest next year if you are into space. I can't say what. And of course, thank you to Dave Kilkenny, and we had Mokina there as well at Sutherland, and Alan, who was popping in and out, and Clyde, and of course to all of you for coming out on a Sunday evening and helping us to spread the joy and excitement of maths and science, and especially space. And of course, thank you to Nicola for arranging all of this as well, and to our global audience. We've got quite a few global members of the audience who are watching. Right now, at the moment, there are 34 live viewers, but that could be a class or group of people as well. So we'd like to say thank you very much for joining us, and we would like to bid you all farewell, and let's go and check out the stars outside. Have you got something warm to wear? Excellent. All right. So thank you, guys.
Thank you very much. Do you have a moment? I just got an image that I would love to share with you before you go outside. So
okay,
which one last one. It's called 2014 October 19, and it says R. Ligustri, Mars. And also I want to make one correction. I'm at Space Science Institute, not NASA. But I work with lots of
Space Science Institute. This one here. Hopefully this is the picture you were talking about.
Yeah. This one was taken this morning, so you can see both Mars and the comet before as approaching close approach.
Here we go. Let's have a look. Wow! So you can actually see the comet there moving.
And this was taken. It was taken in the Robotic Telescope Network Eye Telescope from Australia by amateur astronomer Rolando Ligustri, who's in Italy. So this is done remotely, but it's a fantastic image, and we're hoping to add that South Africa will add more to this timeline.
Fantastic. So thank you so much. All right. So we're going to bid you all farewell. We will see you. Let me just. There we go. So I'm back again. Let's see if it's working. Yes, okay. So thank you very much, guys, and I'll be emailing you all the links and all the photos and everything. It was fantastic.
Thank you.
Okay, so we're going to stop the broadcast.